My dear friends, welcome to Rajashekhar classes on applied data science with Python. This is lecture number 428. In this lecture, we will try to understand few key points with stacking. If each of your base models, that is H1x, H2x, H3x, are more distinct or more different, if these base models are more different or more distinct, then the better typically the better stacking tends to work. That is h1 comma x comma h2 of comma x comma h3 of x. If these are more different, these models are distinct models, then the better it is, better the stacking is going to work. I have seen in Kaggle computations, stacking is the default thing that developers does. That is important. I have seen in Kaggle computations, stacking is the default thing that everybody does, isn't it? People actually form teams. Let's assume we have team of 3 people. Let me say each person each person in the team goes and trains. Person 1 may train 10 models, person 2 may train 20 models, person 3 may train 5 models, isn't it? They go and train these models independently because they go and train these models independently based on their own skill sets, and finally they will combine all these models using stacking. So actually stacking becomes very popular because of computations like Netflix price and Kaggle computation. So if you are doing anything in machine learning in a competitive environment, stacking is a must. If you are doing computation in the real world, stacking is seldom used because look at the cost of stacking. So imagine cost of stacking is actually a lot. You have to train lots of base models, C1, C2, so on, Cm. I have seen cases where people train hundreds of base models. Look at the evaluation time or runtime. Even training time could be massive because you have to train all these models are independently, and then at runtime or evaluation time, given a query point xq to determine yq, you have to run all of these models and meta meta classifier. You have to run these base models C1, C2, so on, Cm, and meta classifier on top of it. So what happens is stacking, from my own personal experience, I have seen stacking being used less often. Stacking being used less often than boosting and bagging. I have seen boosting, especially gradient boosting, GB gradient boosting, and bagging, that is random forest. I have seen boosting, especially gradient boosting, and bagging, especially random forest, a lot in my own experience. I have not seen stacking being used in production models as much. I have seen it in some cases, but if you got competitive setting, if you got computations like Kaggle or any other machine learning computation, stacking is must, because there are teams trying out thousands of models. I have seen hundreds, even thousands of models sometime, and they just try to stack them together, because in computation what matters, the difference between first prize and second prize is very suppose, let's assume I have some metric, let's say log loss. Let it be log loss, average log loss or mean log loss. First prize winner might get log loss of 0.234, let me say 0.234. Second prize winner might got log loss of 0.2341. The second prize winner has has lost because why he's lost, because the difference between first price and second price, so the is small. The difference between first price and second price is so small, so the probability, the money given, so the probability, the money given to first prize winner is significantly more than second prize winner, isn't it? So typically in competitions, the difference between first prize winner and second prize winner is less than 0.1%. Improvement matters in competition, but in the real world, probably increasing your model by 0.1% may not matter, because if you're improving a model by 0.1%, but at what cost? If you train 2000 models for that if you train 2000 model for that prohibited, because training 2000 model, running them in production, ensuring that the runtime engineering challenges in running all these models and training these models is not trivial. It's not trivial. Your manager might say, I don't do like crazy stacking for just 0.1%, because it's not going to help us in real world. So stacking less often, so I can say so stacking is less often used. I am not saying it is not at all used, less often used in real world than boosting and bagging. While in competitive settings, stacking is everywhere. Everybody uses stacking in competitive settings. If you go and read any Kaggle winner solutions, if you just Google search for it, Kaggle actually has blogs winner solutions for some of the competitions. 99% chances that they use some form of stacking. Not always, maybe so much for deep learning problems, but for most problems, stacking is bread and butter. So it's important to note that the difference between Kaggle and real world, that's important. We have a short video of this how Kaggle and real world are slightly different from each other as far as real world considerations are concerned. We will try to discuss this in future classes, how Kaggle is different from real world. Just go through this lecture. If you have any difficulty, please keep a comment. Thank you very much.